Solution by scale drawing is not accepted. Diagram 6 shows a quadrilateral. Point E is the intersection point of straight lines AC and BD. Continue to read the question. It is given that the area of triangle ABC is equal to the area of triangle BCD, and they give that the length of AE is 4 cm, angle of ABC is 143 degree, and angle BCD is an obtuse angle. Okay, let me read the question part A. Calculate angle of BCD, the length in centimeter of CE, and the length in centimeter of BE. So this is for the part A. Okay, for the part B, sketch a triangle A prime, B prime, C prime, which has a different shape from triangle ABC, such that A prime, C prime is equals to AC, B prime, C prime equals to BC, and angle B prime, A prime, C prime is equals to angle BAC. So as you can see here, you have three set of conditions, so please take note. Hence, state the size of angle A prime, B prime, C prime. Okay, so this is the overall question. Okay, so take your time to solve this question, and we will begin our discussion in the count of 5, 4, 3, 2, 1. Let us begin our discussion for the question 14a part 1. Okay, as you can see on the right hand side, this is actually the screenshot of diagram 6. Okay, so let us start our discussion, but first we highlighted what is the information given by the question. Okay, they gave that the area of triangle ABC is actually equal to the area of triangle BCD. Okay, so that is actually very important information. And then they gave us that the angle ABC is actually 143 degree. Okay, so for the question A part 1, we are required to find the angle BCD. And before I forget, I just want to remind you that angle BCD is an obtuse angle. Okay, why am I emphasizing this? Okay, later on, once we finish the working, you will find out why am I emphasizing this. Okay, but for the time now, you just follow along with me in the working. So from here, in order to solve this question, what we're going to do is we're going to equate the area of triangle ABC equal to area of triangle BCD, because that is the what highlighted by the question. And then from there, we can able to find the angle BCD. Okay, so from here, area of triangle ABC, okay, is equals to area of triangle BCD. Okay, so from here, in order to find the area of triangle, okay, please recall back the solution of triangles chapter. You can use the half AB sine theta. Okay, AB is the two lines which is joined together and form an angle, and that angle is called as the theta. Okay, so from here, let us start with the triangle ABC. So from here, 1 over 2 times with AB. Okay, it start from 2.8. Okay, and then times with 3 centimeter. Okay, and not to forget the angle sine 143 degree. Okay, equals to area of triangle BCD. Okay, so from here, 1 over 2 times with 3. Okay, the first length followed by the second length, 3.6 sine theta BCD. Okay, solve the left hand side equation. You should be getting 2.5276, okay, equals to, so half times with 3 times with 3.6, you should be getting 5.4 sine angle BCD. Okay, so from here, in order to get the sine angle BCD, 2.5276 you divide with 5.4. So from here, sine angle BCD, you should be getting 0.46807. Okay, so from here, in order to find the angle BCD, what you do, you sine inverse 0.46807. So from here, you get your angle BCD is equals to 0, oops, not 0, 27.91 degree. And if you think this is the final answer, you are wrong. Okay, why am I saying you are wrong? Because take a note at the question carefully. They mentioned that angle BCD is an obtuse. Okay, so this is the reason why am I emphasizing you that it's an obtuse angle, because in your working that some of the students will just left out BCD just like that. Oh, I already find the angle BCD, I'll just write it just like that. Trust me, you will not get a full marks. Okay, so from here you still need to add on one more step, since you need to find an obtuse angle. Okay, obtuse angle is an angle which is more than 90 degree but less than 180 degree. Since this one is an acute angle which is an angle less than 90 degree. So in order to find obtuse, what you need to do, 180 you minus with 27.91 degree, and there you go, you should get your answer. Okay, so let me just move this screenshot image down. Okay, let me just adjust a little bit. Oops. It's slow. Right. Okay. So from here, since angle BCD is obtuse, okay, add one more working. So from here, angle BCD is equals to 180 degree minus with 27.91 degree. You should be getting angle BCD is equals to 152.09 degree. Okay, so this is your final answer for the question 14A part 1. Let me just underline the solution. Okay, we are back with our discussion for the question 14A part 2. Okay, so from here, before moving on into solving, so I just want to highlight one of the key important steps. Okay, so from the information given by the question, length AE is given as 4 centimeter, and in this case we are required to find the length of CE, the small portion over here. So from here, the first step what we need to do is we need to find the entire big length itself, which is the length of AC. So once we figure out the length of AC, to find the length of CE is actually very simple. So what you can do is AC, you just minus off with the length AE, you'll get the remaining length CE, which is this portion over here. Okay, so how to find out? Okay, I'm going to discuss it with you now. Okay, so please stay with me. So from here, part 2. So from here, to find CE, so the first step what we need to do is we first find the AC first. So from here, in order to find the AC, what we can do is we can use the cosine rule. Since we already have the angle ABC over here, and we have two adjacent length, so we can straight away use the cosine rule and we can immediately find the length AC. So from here, AC square is equals to AB square plus with BC square minus 2 times with AB times with BC, okay, times with cos angle ABC. Okay, so from here, let us key in the values. So AC square equals to AB is 2.8 square, okay, plus with BC is actually 3, so 3 squared. Let me just write it properly. I don't want later on you guys misinterpret it as 8. Okay, and then minus with 2 times with 2.8, okay, times with 3 times with cos angle 143 degree. Okay, the 143 degree is actually the angle ABC. Okay, so calculate this, you should be getting AC square. Okay, key in your calculator, you should be getting 30.257. So from here to get AC, what you do, you square root this value. So from here you get your AC is 5.5 centimeter. Okay, so that is your step 1, finding AC. So from here, therefore, to find CE is actually equals to AC, okay, the entire big length, and then you minus with AE, which in this case is 4 centimeter. So AC is 5.5, AE is 4 centimeter. So you solve this, you should be getting your answer is 1.5 centimeter. Okay, so this is your answer for the question 14A part 2. Let us continue our discussion for the question 14A part 3, okay, where we are required to find the length in centimeter of BE. Okay, so from here, in order to find the length BE, the first step what you are required to do is you need to find the angle BCA. Okay, so that is the very first step you need to do. So how are you going to find the angle BCA? So by applying the sine rule. So you can relate the length the length AC with the angle 143 degree, and you can equate with the length AB with the angle BCA. Okay, we know the obtuse angle BCD 152.09. However, we don't know the small angle here. So this small angle we need to find first using the sine rule. Okay, and once we find this small angle over here, we can straight away find this small length BE over here by applying the cosine rule. Okay, how do we apply the cosine rule? We already find the length CE in the previous discussion, which is 1.5. Okay, and over here you have the 3, and we already have the inside angle over here, so you can straight away find the length BE using the cosine rule. Okay, so this is the overall idea on how we're going to solve this. Okay, let us begin to solve the question, part 3. So from here, applying the sine rule, so from here 2.8, okay, divide with sine angle BCA equals to 5.5 divide with sine 143 degree. Okay, so from here, in order to find the sine angle BCA, so what you do, 2.8, it is 2.8, you times with sine 143 degree, okay, and then you divide with 5.5. It is one of your first step. So from here you should be getting sine, wait, let me write this properly. Sine angle BCA is equals to 0.3064. So from here you should get your angle BCA is equals to 17.84 degree. Okay, so this is your step 1. Okay, once we get the angle BCA, now we can proceed to find the length BE, so it will be much easier. So from here, BE square equals to, okay, BC square plus with EC square minus with 2 BC times with EC times with cos, times with cos angle BCA. Okay, so let us apply in the values. So BE square equals to BC square 3 square, EC square, okay, EC square is 1.5 over here, 1.5 square, or CE square, okay, either way if you wish to call. So minus 2 times with 3 times with 1.5 times with cos angle 17.84 degree. Okay, so from here BE square is equals to, okay, so you calculate all this, you should be getting 2.6828. So to get BE, what you do, you square root this 2.6828. So from here you should get your BE is equals to 1.64 centimeter. This is your answer for the question 14A part 3. Let us continue our discussion for the question B part 1, where we are required to sketch a triangle of A prime, B prime, C prime, which has a different shape from triangle ABC. Okay, this is the triangle A, B and C over here, such that A prime C prime is equals to AC, B prime C prime equals to BC, and angle B prime A prime C prime equals to angle BAC. Okay, so from here we can conclude one thing. So this two position is literally fixed. Okay, the position AB and position AC is literally fixed, so we cannot change this, because if we change this, then the angle B prime A prime C prime will not be equal to angle BAC. So this position we have to fix. Okay, and the same time they ask us that the length of BC must be equals to B prime C prime. Okay, so from here what we can do is we can form an isosceles triangle over here. Okay, which has the same length of 3 centimeter. Okay, we extend until here, and from here we can just straight away connect the B and extend it till down here, and this is technically will be our B prime. Okay. So let me just redraw here the new triangle. Okay, we have already done our sketch of a new triangle, and this is how your new triangle looks like. So you can even double check with the condition, and you can find that it's literally fulfilling the conditions that given by the question. Okay, the first condition is A prime C prime is literally equals to AC. Okay, the length of B prime C prime is equals to length of BC over here, because they are literally an isosceles triangle. Okay, like we have explained over here, 3 centimeter and 3 centimeter respectively, and the angle of B prime A prime C prime is equals to the angle of BAC. Okay, so this is our triangle over here, and let me include some of the important angle over here. So from here, angle of ABC is actually 143 degree. Okay, this small angle is 17.84 degree. So this angle, okay, let us perform the calculation. So 180 degree minus with 143 degree minus 17.84 degree. So from here you should be getting 19.16 degree. Okay, so this angle will be 19.16 degree. Okay, let us proceed our discussion for the question part 2. So for the question part 2, in order to find the angle of the A prime, B prime and C prime is actually very simple. Okay, where is the A prime, B prime, C prime? Actually is this angle. x over here. Okay, how to find the x? Okay, take a look at this small triangle here. It is actually an isosceles triangle. So what we can do is we can actually find this angle x degree. So how do you find this x degree? So 180 you minus 140 degree, 143 degree. So you minus them, so you should be getting the angle over here, and this angle, since this triangle is an isosceles, so these two angles should be the same. Okay, so from here, angle of A prime, B prime, C prime is equals to 180 degree minus 143 degree. So from here you should get your answer is 37 degree. Okay, this is your answer. Okay, we have come to the end of discussion of SPM 2021 paper 2 question number 14. I hope you find this video useful. If you like this video, make sure that you hit the like button. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming Math tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.